With this project, we wanted to explore explaining the latest generation of diffusion models for modeling protein structures. So this generation of models uses an interesting trick using a variational autoencoder to encode all atom protein structures into a backbone representation and a latent space representation. This latent space for each amino acid becomes a single vector for each of the conformations, as well as the amino acid identities, and it has some nice properties which we wanted to show with this visualization. The backbones can be learned by diffusion, and this happens by taking the ground truth data and then gradually noising it out into this fully noised state. And then the model is trained to learn the reverse process to reverse it back to the original state. The latent space, which I'm showing here on the left, projected into 2D, can similarly be used to train the model to diffuse and to generate the protein sidechains. As you can see here, each point represents an amino acid, which gets decoded into this specific conformation here. We can see that it's colored by the different amino acids, so they cluster in this space, and we can also select by different kinds of coloring of the different properties. For example, we can also color by the rotamer strain, and we can look at this island here, where we can see that here on the bottom right, where I'm also showing the rotamers, we can see that there are these islands of high strain and these islands of low strain. So these together form nice properties and form an interactive visualization tool that we can use to study and understand these models.